assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
All right, so here we've been given three different compounds. We have Li2O, we have K2O2, and then finally we've been given CSO2. And what we've been asked to do is to assign charges to the oxygen-containing anions that are in each of these compounds. So first, we need to make sure we know the difference between the cation portion of the molecule and the anion portion. So the cation portion of the molecule is the positively charged region, and when you're writing an ionic formula, the positive cation part comes first, all right? So you have your cations first, and then the negative anion part comes second. So what we'll be looking at is kind of the second half of the molecule, the oxygen. Now, when you're writing an ionic formula, the goal is for the positive side of the molecule to balance out the negative side. So the way we're going to determine what the charge of the negative side is by first looking to see what our positive charge is, all right? Now, the way we're going to determine that is by looking at those first elements in our compound. In this case, those elements are all located in group 1 on the periodic table. You have lithium, potassium, and then cesium, all right? And so since they're in group 1, they have a tendency to lose one electron, which results in a positive 1 charge, all right? So each of these atoms by themselves will take on a positive 1 charge. Now, what we also have to account for is how many of those atoms there are in the formula. So for example, in this first one, since there are 2 lithiums that each have a +1 charge, that means this total cation side of the molecule will have a positive 2 charge, all right? So what that means, if we're going to balance things out, is that the oxygen side must be a -2 as well. So for our anion, we have one oxygen that's hosting a -2 charge. Now, let's look at the K2O2, for example. Okay. So here we again have potassium, which is +1 in its charge, but we have 2 of them. So again, this means that this entire cation side of the molecule will be a +2. So to balance that out, that means the anion side needs to be a -2. So in this case, we have O2 kind of sharing a -2 charge, right? Then finally, we'll come over and look at our last compound, CSO2. So here we have cesium, which is a +1 charge, but we only have one of them. So the positive side of the molecule has a +1 charge overall, which means the -1 side of the molecule must have the negative side of the molecule must have a -1 charge overall. So we would have O2, this time with a -1 charge.